Okay, this is how to do the assignments on page 186. The first one that we're supposed to do is number 13. And if you notice here, it's a three-dimensional Pythagorean theorem. And it looks a little confusing, but this line, the black line, goes from the lower left-hand corner to the upper right-hand corner, or the far right-hand corner of the room. If you notice here, we aren't talking about from the diagonal across the front of the room, but rather through the air across the room. So what we need to do is to have a three-way Pythagorean theorem. Or in other words, we'll take the square root of 28 squared plus 14 squared plus 9 squared. And we get that the room is 32.5. I guess we would have to round it to get the right number of, well, hold it. No, the 9 feet is only 1 sig fig, so the best we could do would be to say it's 30 feet is the diagonal. Next one. What we've got here is squares, and we know the diagonal here is 51 millimeters. So I'm going to get one square here. Let's see. Here's one square. And so the diagonal is 51 millimeters. That's this side squared plus this side squared. Or in other words, 51 is the square root of 2 sides squared. Square both sides, you get 51 squared is 2 sides squared. Divide both sides by 2, you get the side squared is 51 squared over 2. And then finally, we're going to take the square root of both sides, and we get the side is 51 squared square root over 2. So let's do that math. Square root, fraction, 51 squared over 2. And it makes sense that the side would be about 36 millimeters. Next, we're supposed to find the length of this sidewalk here. So what we have to do, if this right here is 405 feet and this is 398 feet, it's not actually a perfect square. It's a little bit shortened from that. So we want to find the length of that sidewalk, and we would take square root 405 squared plus 398 squared. And we get about 568. You got to round to 3 sig figs to get the right number of sig figs both directions. Number 16. Oh, I wanted to get a different picture than that one. I'll just use this picture. Okay, let's say that the house, the ladder had been against the wall here, straight up and down. And this ladder is 14 feet long. This distance from here to here is 37 inches. So we need to know how far the ladder is from the house. What is this distance here? Okay, so what we've got, I think the best thing to do would be to, let's leave it as feet. Now let's change it into inches. So we know the hypotenuse, and if you know the hypotenuse, you subtract. So it's 14 times 12 squared, because we want to switch it into inches. Subtract 14 times 12. So we want to know what the length of this wall here is, since it's 37 inches shorter than that. So 14 times 12 minus 37. And then remember, you have to square it, because that's that side squared. And that tells us that this distance here is 105 inches. Let's see here. Next. Here's a pile of sand or gravel, excuse me. It's in the shape of a cone, and what we want to do is we want to see what the height of the cone is. This distance right here is 117 feet. That's that. And the radius here is 416 feet. I'm sorry, not the radius, the diameter of that cone. So you can't see the whole picture, but if you could, you would have a cone that would be shaped like that. So it's 416 feet. Well, the thing is, if we know the diameter, to find the height of the cone, we would take 416 divided by 2, because that's half the cone. So on our calculator, we are given the hypotenuse once again, so we're going to subtract, and it'll be the square root of 117 squared minus fraction 416 over 2 squared, and we get, ooh, what did I do wrong? Well, let's just start it over again and see what, maybe we better, well, let's just do 416 divided by 2. Let's just do that math, and that's 208 squared is, now, what am I doing wrong? Oh, I see what the problem is. It's not 416 feet. It must have been 208 before. Sorry about that. So this distance here is already 208. So this would be 104. Sorry. So let's 104 squared, and we get about 54 feet tall. Next one. We want to know what the distance is between the axles on this pickup, or this tractor. Okay, so we want to know from the center of this axle to the center of this axle, knowing that this is 47 inches, this is 39 inches, and this distance is I'm sorry, that's not right. 134 inches. Okay, so what we really need to do is to redo this triangle that we get a Pythagorean theorem thing going here. And so we're looking for this distance, the hypotenuse of that triangle. And to find that, we're going to take the square root. Remember, if you're looking for the hypotenuse, you add the two things together. So we have the long side is 134 inches. Add. Now here's where you're going to need to do some math, because we just want to know how far it is from the axle down to even with the front axle. And to do that, we're going to just take 47 minus 39 and square that difference, which is actually what, 8 inches. And we find that it's just over 134 inches from the front tire to the back tire. That hypotenuse is almost the exact same. In fact, it's only a 1/4 inch different than if the tire would have gone straight back. Next one. We're supposed to find, I gotta see which angles are we supposed to find in this one. This is number 20. Let's see here. Number 20 goes with 35. Oh, that's on the previous page. We're given two exterior angles here. Oops. I'm going to get my clipping tool. Okay, we're given two exterior angles, and we're supposed to find the third angle. Well, this angle here, oops, that didn't work out so good. So let's do of the blue triangle right here. We've got two exterior angles here. This angle, of course, this exterior angle here is 90 degrees. This exterior angle over here is 145 degrees. We want to know find the three interior angles. Well, this one is obviously 90. This one is what is that, 35? 35 and 145 is 180. And so this one up here must be 55, because those three angles inside have to add up to 180. Next one. Over again. Alright, so the distance all the way across is 12 millimeters. We want to know what it would be to go from the diagonal to the far diagonal. To do this problem, I'm going to draw it looking straight on at the nut, and I'm going to draw this part is 12 millimeters, and this is what we're looking for, which is part of an equilateral triangle where these are the same length. Let's call this D for the diagonal. This would be half of D. Now remember, when we get done, we want the whole diagonal, not just that part there. So we have D squared, that's the hypotenuse, is half of D squared plus half of 12, which is 6 squared. or d squared is 1/4 d squared plus 36, or 3/4 d squared is 36. Multiply both sides by 4/3. So that you get d squared is 48. So d is the square root of 48. And then remember we have to double it, so times 2. So on our calculator, remember you have to double it because d is only halfway across. So double that and you get 2 times square root 48 is 13.9. So we would say 14 millimeters straight across. Next one. This is like number 27. We're in Washington, D.C., and what we're given here is a drawing of, or a Google Earth of downtown Washington, D.C. And we're supposed to figure out, the distance here. I'm going to do it in blue. Knowing those other two distances. Well, the first thing to realize is what you've got here is two triangles that are similar. This angle and this angle are equal. This angle and this angle are equal. And this angle and this angle are equal. If that's true, then for the top triangle, we have two sides. The parallel side is 650.31. The slanty side is 672.98. For the bottom triangle, the straight side is 342.99. Now I want to make sure that I get these set up right. This is the parallel side, and this is the slanty side. This is the top triangle, and this is the bottom triangle. So we're looking for this part right here, and we find that by cross multiplying and dividing. So on our calculator we would press 672.98 times 342 divided by 650.31 is, I think those were yards. Yes, or meters, excuse me, meters. So our answer is we have to get 5 sig figs, 354.95 meters. And that's the assignment for this lesson.